This is going to be a velocity example. So here's our equation. The velocity is the change in distance divided by the change in time. Now this equation simplifies to the distance something travels divided by the time it takes to travel that distance when, so that this, v equals d over t is true when the initial distance is 0 and the initial time is 0. So we can see that from, here, let me write it in. So this part right here, the delta d over the delta t would actually be, of course, d final minus d initial. Oops, d initial. Sorry, that's kind of messy. Over t final minus t initial. And so if the initial distance and the initial time are 0, then it just reduces to d over t, where d is the final distance from 0 and t is the final time from 0. So let's do a quick example. Suppose we had, let's say, a car that travels a distance d. So we're going to assume, if it doesn't tell us an initial value, we're going to assume that it's 0. That's a safe assumption. Let's say that it travels, 25 kilometers. And it does that in a time of, let's say, 35 minutes. Okay, so 35 minutes. And we want to know what the velocity is, or basically the average speed is another way of looking at it, in units of kilometers per hour. Well, you notice that the distance is already in kilometers, so that we're good to go there. But the time is in the incorrect, is not in the correct units, and so we need to change 35 minutes into hours. So, and this is this is a typical kind of thing with these problems of 3 variables, where you'll usually have to change at least one thing unit-wise. Okay, so here we go. So now the thing about this is you already know the conversion factor. Everybody should definitely know that there are 60 minutes in 1 hour. Okay, so that's the conversion factor. That's what we call a conversion factor. So we have 35 minutes. And notice I write MIN for minutes. Oops, it didn't come out that time. MIN for minutes, and you reserved little m for meters. All right, and so actually, let me do this a little further down. So this is 35 minutes, and we know that, remember, you use this fraction, you put the conversion factor in, and so you're going to do it in such a way, one of these 1 hour or 60 minutes goes on the top and the opposite thing goes on the bottom. All right, well, since we have minutes right here in the numerator, I'm going to put 60 minutes in the denominator and 1 hour in the numerator. And so notice the minutes conveniently cancel. So it's really 35 divided by 60 hours, whatever that fraction is in decimal form. So that's going to be 35 divided by 60 is 0.58, let's say. It's like 0.58 and a repeating 3. So 0.58 hours. All right, so now we're actually ready to do the problem, which again, because now we have the units of time in the correct unit. So it's going to be 25 kilometers divided by 0.58 hours. And so the velocity is 25 kilometers divided by 0.58 hours. And remember, the problem itself told us what to put the units in. So 25 divided by the 0.58333, I get 42.86, let's say 42.86. So 42.86. You could have rounded that to 42.9, even 43 is close. And of course the units are what units matter, as well as the numerical value, kilometers per hour, right? Because the original problem asked us, what is the velocity? Here it is right here. What is the velocity in kilometers per hour? Okay, so that's going to be very similar to one of your homework problems, or several of your homework problems. All right, here's another example of velocity is distance over time. Again, we're assuming that the initial time and the initial position are 0. There's a special speed. It's really the ultimate speed in the universe, the speed of light. And the speed of light gets its own symbol. So it's a speed just like any, well, I guess maybe not quite like any other speed, but the speed of light, so it's the speed of light, has a special symbol that we don't use as a V, we use C. So C is considered the speed of light, and so what that means is the equation C is equal to D over T, right? So that's when something's traveling at the speed of light. Now, the speed of light is a very well-known value. We've measured it time and time again for the last about 150 years, and the value of it is 3 times 10 to the 8th meters per second. Okay, so there are times when we're gonna need that. Let's do a quick example. Here's our example. So suppose that we have some light, or a radio wave which also travels at the speed of light. Let's say that the light travels for a time of, I don't know, how about 14.7 minutes. Okay, and what we want to know is how far did it go? What's the distance? And if you think about it, if this is the fastest thing there is in the universe, that distance is going to be as far as something can travel in a time of 14.7 minutes. So we're going to use this information. The speed of light is 3 times 10 to the 8th meters per second. We're going to use, notice it's meters per second, so we're going to need to change minutes here to seconds. So we already know the conversion factor. All right, so 14.7. Remember, I use MIN for minutes. And so we know that in 60 seconds, there's 1 minute. 1 minute. And so the minutes cancel, just like numbers, the units can cancel as well. And so let's see, what is 14.7 times 60? I get 882 seconds. So it's 882 seconds. All right, and so what distance does the thing travel? So now that we have this time in seconds, we can take this original equation, the speed of light is equal to distance over time, and solve for d. All right, and so we have that d well, I guess I should do this step by step. D over T, that's equal to C. And so algebraically, what I'm going to do is multiply both sides by T. What I do to one side, I have to do to the other. Well, I don't have a lot of room for that over here, but that's T. Sorry. Here, I'll do that over here. All right, so this is going to be T times C is equal to D. All right, because I just multiplied both sides by T, the T canceled. The T that was in the denominator right here canceled. And so now we put the numbers in, right? So we have 800, what was it, 882. So 882 seconds times 3 times 10 to the 8th meters per second. And that's what the distance is, all right? So, all right, and hold on, let me pause this. All right, so I just got myself a little more room here. So here we have 882 seconds times 3 times 10 to the 8th meters per second. So that's going to be our distance, right, when we multiply this out. Let me just say something very quickly about 3 times 10 to the 8th. Now, when you enter that into your calculator, make sure that you never hit times and you never hit 10. You don't do that. The way that you enter that into a calculator is, if you have a Texas Instrument, for example, it's 3 and there's an EE button, and then you hit 8. Okay, so the EE button, like in my calculator, I have to hit Shift. If you have a Casio, it's 3 and there's an EXP, which is the exponent. So that's this. Both of these mean 3 times 10 to the 8th. All right, but this is the way a calculator sees it. This is the way, another type of calculator, a Casio, would see it. So this first one is Texas Instrument. The second one is a Casio. If you have something different, you'll have to figure that out. All right, so here we go. Well, actually, I'm just going to calculate this. So I already have the 882, so I'm going to say times, and then it's 3, and for me I have to hit Shift EE, okay, and to the 8th, and then hit Enter. And so the answer that I get for the distance that's traveled in, what was it, 14.7 seconds by light or a radio wave or a microwave, all of them travel at the same speed. So the distance is going to be, so make sure you do this example until you get it right, so that you know that you really know how to use your calculator. So it's 2.6, it's like 4.6. I'm going to just say 2.65, and it's time, and so I have an E11. So the way you write the answer is, that literally means times 10 to the 11th, and if you go back up here, it's meters per second times seconds, so the seconds cancel, and so your answer will be in meters. And of course it should be, because we're talking about distance. All right, so there's a good example of you doing velocity with the speed of light.